Hello everyone and welcome back to another video. Today we'll be taking a look at the evaluation function within the engine evaluation within our chessbot. So in the previous videos we've covered the foundation functions, the user interface side of things, as well as all the legal moves. And in the previous video we looked at the is under sphere attack function within engine evaluation. Today we'll be taking a look at the main function within engine evaluation, which is evaluation. So what this does is this basically determines the static evaluation of a particular position. So given a certain board arrangement, it determines what the whether that's better for white and or for black, and what's the quantitative measure of how good it is for either color. So and now let's have a look at the actual program. Basically, if you want to follow along on GitHub, as I'd recommend you do, it's basically on line 479 over here. And now let's go through this. So as I mentioned earlier, this gives us static evaluation, but then we have several different criteria in chess, which determines whether an evaluation is good or not. So I'm assuming that you're familiar with the basic rules and principles of chess. So as a beginner, we're taught a few main things. First of all, we're taught that having double pawns, that's not very good. So this has to play some sort of role in the evaluation function. We're also taught that putting rooks on open files, that's good. So that also has to have a role. But then the most important thing is the actual piece values. So these piece values are the main part. And what they basically do is each piece has a certain value associated with it. And these values, if I go up to the very start of the code, these are the corresponding values for each of the pieces. So the value for a pawn is basically 1, and bishop knight are 3, a rook is 5, queen is 9, and the king's 15. Now, normally in chess, you'd see the king to be worth 200. I mean, technically it's worth infinite, since the entire point of the game is just to protect the king. I was finding that we were encountering a few major issues with having the king's value is 200. And now these issues will come on to exactly why and how they arose in just a second. But now let's go back to our main function. So the first main thing which we need to do is just add up all the piece values within for white and for black, and then we'll basically determine, we'll go from there. So the first thing which we do is the evaluation in chess is basically it's a positive number if it's beneficial for white. So let's say the evaluation is plus 1.5. So this basically corresponds to roughly a pawn and a half worth of advantage for white. And now likewise, if it was minus 6 for black, that would correspond to roughly about 6 points within material of an advantage for black. So which is why rather than just subtracting and adding from the evaluation straight up, what I've done is I've assigned a weight. So what this weight does is this basically scales whatever the value is by 100. So what this means is that, let's say the piece value is 1. So for every pawn, we'd basically add 100 to the weighting. And then this basically allows us to just divide it by 100 in the end. And then this will basically give it to us within 2dp. It gives us a bit more precision with our actual values. Okay, so now let's have a quick look at how exactly we determine these different things. So the first thing which we do is we just add up all of the piece locations. So within whatever the piece value is, we multiply by 100, then add it to the weight of that particular color. And we only do this if there's a piece on that particular square, obviously. Now we have one more thing. So this basically determines whatever the optimal locations of each piece are. Okay, so and now let me just go up to the very start. Pretty much, what the optimal locations are is they're basically a measure of how optimal a particular square is for each piece. So let's have a quick look at an example of this. Okay, so for example, I basically just I outputted what the optimal piece locations are for certain pieces. So for example, if we just run this program now, it basically gives us which optimal locations there are for each of the pieces. So the first piece which there is it's basically a pawn. So now if we imagine for a white pawn, the squares which are basically optimal, the squares which would be optimal would be as close to the 7th rank as possible, right? So, which is why all of these are set to 50. So 50 is basically like as good as it gets for any piece. So ideally, if you can move the piece to one of these 50 squares, that's really, really good. And now if it's like to the 30s, then that's still really good. And then pretty much you get the idea. Like the lower it is, the better it is. The lower it is, the worse it is. So that's basically for a pawn. However, as I'm sure you'd imagine, this would vary for each piece. So this is for a pawn. However, for a knight, this is basically what the optimal locations look like. So if it's on one of the corner squares, that's very bad. So which is why it's set to -50. And it's pretty much just like as it goes further and further central, it's basically its evaluation increases. So towards e4, d4, d5, e5, these four are probably the best squares for a knight. So which is why they're set to 20. And then the squares just outside of 15, just outside that 10, etc. And now, I won't go through all the pieces, but you get the idea. Like, for a rook, it's like this. And now, if you notice for a rook, pretty much, a rook can be equally good or bad, like, regardless of the square it's on. Like, apart from the edge squares, pretty much any of these squares are, like, similar for a rook. So, which is why, instead of -50 and stuff, which we have for a knight, the range is only from -20 to +10. Because like it's hard to tell whether rook's position is good or not. Okay, so and now like it's similar for a bishop. It's not that easy to tell which square is good, and that's pretty much it. For a king, the squares which are probably best are the corner squares, and now as it wanders more centrally, it becomes worse. However, for a king, this is basically what the squares are in the middle game. However, towards the end game, it's actually good to have like good king activity. Instead for a king, the central squares are probably better, and if it stays in the corner, that's considered to be slightly worse towards the end of the game. Okay, so that's basically the how we determine the optimal locations for each of the pieces. And now let's go back to having a look at the evaluation function in a bit more depth now. Okay. So that's how we determine the optimal pieces. However, one more thing which I've done is I basically scaled how good that particular, how good or bad a piece being on that square is by whatever the value of the piece is. So for example, let's say if a bishop is on a bad square, then it's not really the end of the world. However, if a queen's on a bad square, then that's much worse than a bishop being on a bad square, since the queen has far more potential than a bishop. So which is why it's scaled to being however, whatever the piece value is as well. So all of that, we add that to the weight. And now one more thing which we need to do is we need to account for the double pawns, half open file. We need to account for all of these different criteria within the weight function. So basically, if there's a rook present, then what we do is if the count of the pawns within that particular column is 1, then we append that whatever the weighting given to half open file is to the weight. Otherwise, we append whatever the count of open file is to the weight. Okay, this should actually be 0. So sorry that was a bit of a logical error, but that's pretty much it. So it basically determines if it's an open file versus a half open file. It adds that particular weighting to the overall evaluation. Now, similarly, if there's doubled pawns or tripled pawns even, then what we do is we basically add that particular weight to the doubled pawns. However, one more thing which we need to be careful of here is that we need to basically subtract over here, which is why we should have a subtraction. Since basically, if the count of the pawns is double or triple, that's basically worse. So which is why we take off evaluation points. And now that's pretty much it for this valuation function. And yeah, so this is basically a key. Like the better this gets, the better the evaluation function gets, the better the actual chessboard will perform. Now, ideally, one thing which you could try and do is use like TensorFlow or something, and it developed like some sort of neural network which evaluates functions for you. This would be far more accurate than this sort of heuristics function, if you like, which is it's not super accurate. The more accurate this is, the better. But you could do that if you have like the time and the patience. It's definitely something worth doing. Okay, so that's basically just the evaluation function for this particular video. I really hope you enjoyed watching. Hopefully you learned something new about how we evaluate these chess positions. And I hope to see you in the next video where we'll be taking a look at the core functions. So yeah, thank you very much for watching. Bye.